Alright, for this question, you have to figure out the acceleration of the car when the car accelerates from rest, that's a fact, to a speed of 1 times 10 to the power of 2 kilometers per hour in 7.2 seconds. So all these ones I've highlighted are facts. Acceleration is obviously what we're trying to find. So I'm going to write some stuff down. So my time is 7.2 seconds. My speed, so my v naught is 0 because it's at rest. My v is 1 times 10 to the 2 kilometers per hour, and my a is the question mark. Now I'm going to change this kilometers per hour into meters per second, so it's easier to calculate, which you just go divide 3.6 to get the meters per second. I'll just leave it as that. Alright, so basically the acceleration function is delta v over delta t, which you know is v take v initial, so v final take v initial over the time. So my v is 1 times 10 to the minus 2 divided by 3.6. My v naught is 0, and then I just divide by the times, which is 7.2. Now if I put that in the calculator, hopefully you get 3.86 meters per second. Now B, calculate the distance travelled by the car during the 7.2 seconds. Alright, so what we have to figure out is distance travelled. We also know all these facts. My time, 7.2. My velocity is 1 times 10 to the 2 divided by 3.6 meters per second. I've also got my acceleration, 3.86 meters per second squared. Oops, I just realized I did my units wrong over here. Per second squared, right? And then what else do I know? My v naught was 0 meters per second. So because technically we have all, 5 facts, it doesn't really matter which equation you use. So I'm just going to go with the easiest one, which is always already rearranged, so the last one. So I'm just going to use that one because it's already rearranged to s equals, so I don't have to do any rearranging. Alright, so basically v naught, my s is what I'm trying to find, v naught was 0, so that goes away. It's basically half a t squared. So now if I put that in the calculator, we get about 100 meters. Alright. Calculate the time taken for the car to move 2 times 10 to the power of 2 meters. Alright, so we've got this value that we got given was distance, so 2 times 10 to the power of 2 meters, which you can also write as 200 meters if you want to write it out 10 to the power of 2. Time is what we're trying to find. We know that v naught is 0, and we know that the a is 3.86 meters per second squared. Right, so we have the v missing, so we're going to use this last equation. As you can see, that one's missing v. So just copy it down and then substitute those values in. So my s is 200, my v naught is 0, so that goes away again, half. My a is 3.86, my t is what I'm trying to find. So basically I'm going to move all these to the other side, so half I can times, so it becomes a 400, and then you divide by 3.86, which becomes t squared, which means t is just the square root of that. 400 divided by 3.86 x, which if you chuck that in your calculator, hopefully you get 10.2 seconds. Alright, last one. Calculate the average speed of the car during the first 7.2 of its motion. Alright, so what we're trying to find is the velocity, or the speed in this case. Now, time is 7.2, so I've got to figure out my distance because that's the equation, v equals distance over time. Now, my distance, we actually calculated in part B, so my S was 100 meters. So that should be pretty straightforward, so that if I just sub that value in, my V equals 100 divided by 7.2, which is approximately 13.9 meters per second. So that becomes average speed of the car.